Hi guys, welcome back to my channel. So today is a new lesson of a new unit, okay? So let me introduce our new topic for now. So today and for the next 2 weeks probably that we're going to deal with something called a compass, okay? Today I'm going to talk about how to construct an equilateral triangle using a compass, segment, ray, and lines. Do you see my screen? There are a few options that you could use on DeltaMath. So that means now our all assignments are going to be on DeltaMath. The reason why I'm not recording my paper is that I know some people don't have a compass at home. So that means you could do DeltaMath if you have a tablet or a computer or a iPad or something, okay? So let's get into it. Equilateral triangle, whoopsies, okay? Equilateral triangles, meaning that all sides are equal, okay? So let me read the question. Use a compass and a straight edge to construct an equilateral triangle which line segment UV is one side. Your final answer should be exactly 3 blue line segments, including the one that's already drawn. Okay? I feel like I say okay way too much. This is something that I need to fix. Alrighty. I need to draw a triangle. Equilateral triangle. All 3 sides are equal. They already give me a side. So that means my other 2 sides have to be exactly the same distance as the one that's given to us. It doesn't, so my new triangle, it doesn't have to be exactly one direction, okay? It could be either on the top or it could be on the bottom. If you could see my mouse, then hopefully you could, okay? With that being said, how can I draw a triangle without using a ruler to actually measure? For example, I cannot tell you that line segment UV is exactly 5 inches. So the other 2 lines have to be exactly 5 inches. Okay, I can't tell you that. Plus, it's going to be very difficult for you to actually try to draw 5 inches and try to measure, try to do all that. With the compass, it could be much easier. So let's go ahead and put our mouse on the word compass and click on it. So the word compass should turn into green. And it says click and drag and draw a circle. So you could start with whatever, okay? But I am going to put my mouse on point U and click on it and drag it to point V. So now you could see that there's a dashed circle around it. Now, look at line segment UV. You could realize that I'm going to scroll it down. Okay, you could realize that UV is a radius of this circle centered at U. So that means if I start any line segments from point U and drag it to the circle, it's all going to be equidistant because it's all going to be radius. But to be honest, I don't really know where my third point going to be yet. So I'm going to draw a line. So if you put your mouse on the circle, you're going to see a little pencil. So you're going to draw a line going around the circle. Okay, so that means my other point is going to be approximately over here because I want another line that's equidistant to PV. I meant to UV. Now, if I put my cursor, my mouse at point U, because that was my center of the circle. So if I drag the point to V, do you know that UV still stays as UV? It's still the center, it's still the radius of the circle, but now my center is being changed. My center is at now point V. But no matter how I draw my lines, it's still going to be a radius. It's still going to be the same distance. So now, if I draw a line around my new circle centered at V, you're going to see that they're going to have an intersection, which is at this point right here. What this point is telling me that without only focusing on the circle U, okay, the first circle that I drew, that this point is on the first circle. This point is also on the second circle. I did not change the radius at all. So that means this point is going to be the same distance from point U and from point V. So that means if I click on the word segment, because I'm looking for a line segment to draw my triangle, if I click the word segment, I'm going to start with the intersection. If I draw a line segment from my intersection to point U, and I draw a line from my intersection to point V, and voila, I'm going to have a triangle where all three sides are equal to each other because I'm using the same distance from VU to make two circles. The intersection point is going to be equidistant, or it's going to be the same distance from point U to point V. Therefore, that this triangle right here is going to be a equilateral triangle. All right. Just a little heads up about some people may already know that on DeltaMath that there's a it's not on my screen, but usually it's going to be like a button over here. It says sample or example or sample problem. So if you don't understand my video, DeltaMath actually shows you how to do certain problems. Okay, so you can always look at the simple problems and try to figure it out. Now, I'm having video calls on Google Meet twice a week. Now, if you have any issues with any problems, with any assignments, you make appointment or you join me, which whenever I post the link. Okay, I'm here to help. So hopefully this video helps and I'll see you guys